Okay guys, what I want to do in this video is just work some of the homework problems that I gave you for section 5.2 and maybe some other ones, but we'll start with 5.2 and see how far we get. Maybe this talking through and helping you will be beneficial to you. I am looking at the handout. This is section 5.2. This is page 212 if you're looking at the top left hand corner. And I'm going to start with exercise number 36. Because the other ones have answers and you can figure those out. They gave you tangent of alpha over secant of alpha equal to sine of alpha. Now in our tips and tricks, they tell you to start with the more complicated side. Obviously this left-handed side is the more complicated piece. Another tip they tell you is to try to change things into sines and cosines. So I'm going to do that using my identities. Tangent of alpha would be sine of alpha over cosine of alpha. That is by the quotient identity. Secant of alpha is going to be 1 over cosine of alpha. That is by the reciprocal identities. And then I still have that sine of alpha on the right hand side. Now notice guys, each time I work this problem, I continue to write down the left hand side, the equal sign, and the right hand side. It is very important that you hold yourself some very decent form as you go. Okay, so be sure that you're working on that as you're working problems. Now, on the left-handed side, I just need to perform the algebra operations indicated, and that is division of fractions. When you divide fractions, you keep the first fraction, that is sine of alpha over cosine of alpha. You multiply, and then you reciprocate the second one to join those together. So, on the left-hand side, I'm just working to multiply these together. And obviously, cosine of alpha divided by cosine of alpha is 1. So I have sine of alpha over 1, which is just sine of alpha. And since sine of alpha equals sine of alpha, I have verified this trig identity. Okay, so that was very straightforward, not too bad. That was number 36. Let's look at the next one. We'll go ahead and do it on this page. Number 37. It gives you 1 minus sine squared of beta divided by cosine of beta, all equal to cosine of beta. Again, the more complicated side would be the left-hand side. That's where I'm going to start and work on changing things. And then we're going to move from there. Now this first piece up top, the numerator, 1 minus sine squared of alpha, I recognize it. It is the Pythagorean identity, but it is rearranged. Our normal Pythagorean identity that we know is sine squared of beta plus cosine squared of beta equals 1. Sorry, that's all messy because of that over there. But I can see if I subtracted sine squared to the other side, I would have cosine squared. So, I already know that this is cosine squared of beta on top because that's the Pythagorean identity. And then a cosine squared divided by a cosine to the first just leaves you a cosine to the first of beta on the left-hand side and the right-hand side. So two cosines being equal to each other, that identity is also proven. So the first two were not too terrible, and hopefully that helps you a little bit. Let's look at another one. Sorry about that coughing, I do apologize. Okay, number 40. We have sine squared of beta times 1 plus cotangent squared of beta equals 1. Okay, now I'm going to actually have to do a little thinking on my own. Not too bad. But let's see. This is the more complicated side, the left-hand side, so I'm going to start there again. Sine squared of beta is fairly straightforward. 1 plus cotangent squared of beta looks familiar to me. It looks like a Pythagorean identity, and it is. This is the Pythagorean identity, and it is equal to cosecant squared of beta. Now, by my reciprocal identities, cosecant squared of beta is equal to 1 over sine squared of beta. That's because it's the reciprocal identity. And then sine squared divided by sine squared is just 1. So 1 equals 1, and number 40 is complete. Very good. 41, we have cotangent of s plus tangent of s. Those s's aren't turning out too great, but that's okay. Equals secant of s and cosecant of, cosecant of s. Alright, so both of these sides seem pretty simple, but it's easier for me to go from addition to multiplication than it is for me to go from multiplication to addition. So for that reason, once again, I'm going to start on the left-hand side, which is going to be a little bit more of a complicated side for this amendment. I'm going to change things to sines and cosines just so I can think. Okay, that's the way I think. So cotangent is actually cosine of s over sine of s, and tangent is sine of s over cosine of s. These are the quotient identities. It's both of them in play. And we still have secant of s, cosecant, secant of s, cosecant of s in play. That's crazy enough. Those s's are crazy. Now notice we have just one term here together being multiplied, and over here we have 2. I need to get it down to 1, so I'm going to get a common denominator. That common denominator would be sine of s, cosine of s. I just multiply those together. Having done that, this would have been multiplied by cosine of s on top and bottom, so this would become cosine squared of s on top right here. This side would have been needed to multiply by sine of s on top and bottom, and so this top would become sine squared of s. And I still have my secant of s, cosecant of s over on the right hand side. Again, that was just getting the common denominator. Now, looking at cosine squared plus sine squared, I recognize that very quickly as the Pythagorean identity. If you are not recognizing your Pythagorean identity, you need to study. So that's the Pythagorean identity. And I still have all this stuff over here on this side. Alright, this breaks up into fairly easy pieces. 1 over sine of s is going to be cosecant of s, and 1 over cosine of s is going to be secant of s, and I've just rearranged them. Multiplication allows you to do that. Those were both by the reciprocal identities, and so we have secant of s, cosecant of s equal to secant of s, cosecant of s, and 41 is also complete. 43. We have cosine of alpha over secant of alpha plus sine of alpha over cosecant of alpha equal to secant squared of alpha minus tangent squared of alpha. Okay. Well, I think that I will just start on the left-hand side. It looks a little bit more complicated, and we'll go from there. Secant of alpha is the same as 1 over cosine of alpha. That's by the reciprocal identity. And likewise, cosecant of alpha is 1 over sine of alpha by that same reciprocal identity. Now cosine divided by 1 over cosine actually just becomes cosine squared of alpha. You could flip this fraction over and multiply to see that. The same is going to take place here. This will become sine squared of alpha. Okay, so now the big question is, how do I link these two? Here's what I know, and this is a very simple stuff. By the Pythagorean identity, I know that cosine squared of alpha plus sine squared of alpha is 1. And likewise, I'm, I'm going to do a side note down here. What I formerly have was tangent squared of theta plus 1 equals secant squared of theta. This is also a Pythagorean identity, and I recognize that I could get this 1 by itself by subtracting tangent squared. So this part is actually equal to the 1 just because it's a rearranged Pythagorean identity. So however you want to place that, you can. But 1 is equal to secant squared of alpha minus tangent squared of alpha because that's the Pythagorean identity rearranged. And so you have those two sides set equal. Okay. Let's look at one more. Number 47, we have 1 minus cosine of x divided by 1 plus cosine of x. And all of that equal to cotangent of x minus cosecant of x all squared. I may work both sides here, to be honest. On this side, I would multiply by 1 minus cosine of x, top and bottom. So on top, I would have 1 minus cosine of x all squared. And on bottom, I would just get 1 minus cosine squared of x. Those are not the same, but that is something. Here, I think that I would probably multiply this out. If I multiplied or squared out the side, I would get cotangent squared of x minus 2 cotangent of x cosecant of x plus cosecant of x squared. Okay, I folded that out for those of you who are wondering about all that. Now, this bottom part right here, by the Pythagorean identity, I have 1 minus cosine of x all squared on top, and this is just sine squared of x. I still have all this. Here. Okay, I'm going to go ahead and pull out the top of this part right here. This becomes 1 minus 2 cosine of x plus cosine squared of x. All of this is still over sine squared of x equal to cotangent squared of x minus 2 cotangent x cosecant x plus cosecant squared of x. Now there is only one term in the denominator. When there are two terms like at the very beginning of the problem, we cannot break these apart. But when there's only one term, we can break these apart. So this would be the same as 1 over sine squared of x minus 2 cosine of x over sine squared of x plus cosine squared of x over sine squared of x. Still all of this equal to the right hand side. And I'm writing this painstakingly over to keep good form for you guys, so you know how to do that. Alright, 1 over sine squared of x is cosecant squared of x by the reciprocal identity. Now the next one, I could borrow one sine from this piece to get 2 cosine of x over sine of x, and I still have 1 sine of x left. What I'm doing is I'm just taking that x squared and breaking it apart into 2 pieces. For this chunk right here, cosine over sine is cotangent squared. Alright, so still working. We're going to make it. Now I'm looking, I have a cotangent squared x and one here. I have a cosecant x and one here. So I can rearrange these two. I'm going to go ahead and put my cotangent squared x first. This is, by the quotient identity, cosine over sine is cotangent x. This, by the reciprocal identity, is cosecant x. And then I have my cosecant squared x at the end. And on the other hand, I have this still. Ooh, gracious, sorry. And so the left hand side meets the right hand side, even though it's a little blurry. There is 47. So not so bad. That's 5-2. That's the first page toward the bottom of identities to just give you a little start on those.